So we've hit the top of the hour, but as this is Karsten's agenda, we do need to wait for him to arrive.
Carsten was active on chat just a few minutes ago, so I'll send him a ping. As Carsten's main question will be, do people already have feedback on pull request 42? That time might be spent well just kind of looking at that.
Yep, and Karsten has arrived, so let's go ahead and get started. Welcome to the CBOR call. Thank you for the people who are scribing. Marco, as always, I'm sure, here. And let's get started. Karsten, over to you.
Okay, so it seems we will be skipping the usual share slides because everybody here is a repeat customer. I have made some slides that borrow liberally from the one I used 2 weeks ago. So when the slide looks like this, it's from 2 weeks ago, and if the slide looks like this, it's new, or at least changed. So what's different? We now have a draft pull request. I didn't submit this as an internet draft because it really still requires some redundancy removal. But I think the general direction in which I think this thing is going should be visible. So just as a reminder, this is based on 2 axioms. One is we're not making technical changes to RFC 8949. And I know that Joe is not so sure about that. So at some point we will have to revisit this. But for now, this is one of the 2 axioms. And the other axiom is that this does not extend to defining new terms. So we can define new terms all we want and make sure that they are actually useful. The point of the CDE project is to address deterministic encoding. I don't think I have to repeat that. And we have several use cases in mind. There are probably other use cases, but it's not the job of this document to list the use cases. There's another document that does this. So what we discussed 2 weeks ago was that we really should be talking about encoding constraints or encoding constraint sets. I've given up on the set thing a little bit because it just complicates things. So we have encoding constraints. And the 3 that we are interested in is the preferred serialization, the definite length only, and the lexicographic map sorting. And CDE really is just the conjunction of these 3 constraints. Or if you use set notation, it's the union of these 3 constraint sets. So if anybody of you has a preference whether we should write these as predicates, like the line with the and symbols, or whether we should write this as set theory, as in the line with the union symbols, I'd like to hear that possibly in the chat. The question about a constraint is why are we actually talking about this constraint? And there may be 2 different things going on here. One is that an encoder is trying to meet the constraint. The other is that a decoder actually needs to check the constraint to actually get the benefit of a particular constraint. So these are different normative intents, and we have to be careful in separating these from each other. So apart from CDE, common deterministic encoding, I think we have discussed this for long enough that we can be reasonably sure that we only have one other encoding constraint we really are interested in as an encoding constraint, and that is definite length only. So a lot of people have said this makes my implementation complicated. It's hard to do zero allocation or zero copy with indefinite length. So having a constraint that is named and that is really just only containing the definite length only property might be really useful, and we don't want to do another document for that, I think. So we can piggyback it on the current document. And the reason here is not to get a new property out of the CBOR encoding, like with deterministic encoding, where we know that the same data item gets the same encoding, but just to cater to partial implementations, so implementations that don't do indefinite length can act as decoders on something that an encoder has generated with this constraint. And as far as I know, this is the only kind of partial implementation that we really care about. Of course, we could come up with lots of examples for partial implementations that people might want to do, but none of this will be mainstream enough that you would reference it in a protocol definition. While definite length only really is something that people want to do. So for instance, in Appendix C of 8949, we have pseudocode, and about 40% of the pseudocode is about handling indefinite length. So really constrained implementation would be happy not doing that. And of course, the pseudocode only handles the well-formed check. It doesn't handle the actual chunking that is behind that. That is probably a more expensive part of it. So we liberate the definite length only constraint, no longer combine it with preferred serialization, and that actually simplifies the document appreciably. So just to give an example of what we have had in CBOR-based protocols, the CRI protocol, which is defined in core href24, provides a CBOR representation of URIs, of the semantics of URIs. And that currently has this text, and this text would probably stay where we're not anticipating semantic changes here, but it might be able to use the term that we have defined here. Okay, Joe mentions that non-trivial nans would fit into a simplified ECS. Actually, no, because this is a completely different case. The definite length only constraint is one where you take a data item at the model level and then decide how to encode it. While removing non-trivial nans from the data item, data model level set of items is completely orthogonal to this. You just take out parts of the data model space. So the reason why I'm reacting to this is that this goes into the direction of another slide I will have in a couple of minutes. But maybe, Joe, you want to do this verbally.
I can wait.
Okay. Yeah, so we had discussions about what generic encoders are and so on, and I think we have moved beyond that. So the pitfall we have to avoid is having this really large number of options that people who write protocols or who write implementations actually have to navigate in and are likely to drown in. Also, yeah, I think it's a good idea not to invalidate previous use of 8949. Yeah, I'm going to have another slide on this. Sorry, something is slightly in a different order than I remember. But the result of all these considerations is that we essentially do named encoding constraints. We have 5 named encoding constraints, where well-formed is a somewhat weird constraint because it's empty. It's a predicate that always returns true. And then we have preferred serialization as an encoding constraint, but that is typically on its own not an interoperability constraint. It's just something that's a reasonable thing to do on an encoder. So an encoder will routinely use preferred serialization. So in most applications that just fits, but it's not an interoperability thing. So the recipient does not rely on preferred serialization being used. And I think that it took a while to actually carve this out, that preferred serialization is great on its own, but it's not usually an interoperability constraint. So you would just use a generic decoder in conjunction with an implementation that does preferred serialization on the encoder side. What we want to have as an interoperability constraint is definite length encoding. We actually say this in the href text with the intention that a recipient can rely on this encoding constraint being met by the encoder. So the recipient does not have to implement indefinite length encoding. So this is very different from the preferred serialization situation. And then we have an encoding constraint that just gets a name, but is combined with the other two here to actually create the CDE encoding constraint. And that is, of course, an interoperability constraint because we actually want to have checking decoders that actually check that the deterministic I'm just reading a chat message that confuses me. Anyway, so the CDE, the main objective of this document is the combination of the 3 encoding constraints on this slide, on the middle ones. Joe says well-formed has 2 constraints, no duplicate keys and no invalid UTF-8. That's actually validity, and I have some slides on validity. Well-formed doesn't care whether you have duplicate keys or invalid UTF-8. So that's something we're not that happy about, but it seems like the right thing to do because we didn't want to burden every CBOR processor of any kind with checking for duplicate keys or checking for UTF-8. Yeah, and that's exactly the next slide. So map validity, we have 3 kinds of validity in 8949. One is map validity. So this is the duplicate keys thing. And this is a validity requirement and not a well-formedness requirement because it has a significant implementation burden. So to enforce this, an encoder needs to know all map keys at a particular point in time when it does this check. And streaming encoders cannot do that. So it would essentially remove streaming if it was a well-formedness requirement. And we didn't want to do that. So we invented a second category beyond well-formed, that's the validity. Now, if you are implementing the lexicographic map sorting encoding constraint, you already require awareness of the map keys, because otherwise you cannot sort them. So the check actually becomes trivial because you can just compare the map key of an entry with the map key of a previous entry, which you need to do anyway to do sorting. So given that we have the opportunity to make this check, we could actually have CDE do this as interoperability constraint. Joe.
Sorry, I don't have 8949 up. I should have in order to quote a particular subsection. But I, as far as I remember, 8949 says that you have to operate on the data model, not on the encoded version. And
yes.
So I wish that it had just said you did the encoded version, because then it'd be easy to implement the way that you just said. And we had a small conversation as an aside 2 weeks ago about whether the two were equivalent or not. And I still haven't come up with a good example of when they might not be. But I'm worried that they're not always exactly the same.
Okay. So yeah, we have to check that. Can you create an issue for that?
Yeah, I'll do that right now.
Thank you. Okay, so that's one interesting decision here, that we, because we have the opportunity to do this check, we can make this a part of the encoding constraint, and this gives us map validity as a side product. So the other validity, the text string validity, is different. We have two kinds of strings in CBOR, binary strings or byte strings and text strings. And there is no validity constraint on byte strings because it's just a sequence of bytes. While the bytes in a text string are supposed to be UTF-8. And that means that there is a certain syntax. Lawrence, check what on decoder encode?
For duplicate keys.
Both. So you can do this check. Well, you have to remember the previous, the key of the previous map entry that you have processed, and then you in the checking decoder, and then you can do the comparison. Joe.
So I remembered the case. So if you're not doing deterministic encoding, right, and I've got a map as a map key, then the order of the keys might be different in two keys.
Yes.
And then are they duplicates or not? And I think the way that it's that the text in 8949 says is that they're supposed to be the same, but they might be encoded different.
Right. So we're talking about a specific encoding constraint here, the lexicographic map sorting encoding constraint. And
right.
That actually forces the map keys to be deterministically encoded. But you're right. You need to have the other two.
But deterministic is orthogonal. If we make it to orthogonal, now we've got a question of whether you can do what you just said.
Yeah. So what the slide said is not true, because you might not have preferred serialization or might not have definite length only. And if you use lexicographic map sorting on its own, it's not doing that. And that needs to be phrased in a different way. And Lawrence thinks we cannot require checking encoders for deterministic encoding. Well, an encoder has the situation under control, so it doesn't need to check. But, Lawrence, can you clarify that?
So, I mean, I made a suggestion on the list that we require deterministic encoders to disallow duplicate keys. And I think you said we can't do that because there are circumstances where, you basically said we shouldn't have that constraint. Is that true or not? Is that a requirement or not? I mean, if you are doing deterministic encoding, is it a requirement to not have duplicate keys or not?
Well, we are defining common deterministic encoding to make it a requirement now. So this is
okay, because that is not what you said when I said that last week. So, okay. You definitely did not say that.
Okay.
And I apologize to the list for my mistake and all that. And now you're just telling me I was actually right. So I guess I rescind my apology.
Okay. So I'm not entirely sure I remember this exchange. Yeah, so this is really a decision point here. We can make the decision to require map validity. And this is cheap because it comes with the strict ordering. Yeah, but as Joe said, it's only true for CDE. It's not true for lexicographic map sorting on its own, and we need to make that point.
Well, it also depends on your technique for sorting, for achieving sorted. I mean, maybe it's cheap, maybe it's not, right? Maybe you're producing the ordered thing not by actually running a sort, but by doing something else, right? Some other.
Yes, but at the point where you're actually serializing, you can check that. So if you have a C++ map, for instance, the C++ map or C++ multi-map actually will be happy to take multiple elements for the same key. And if you serialize out of a C++ multi-map, then you have to do the check again. And that's maybe a good reason not to use a C++ multi-map. But I'm just trying to cover all bases here. So you are right. If the way you are generating this sorting doesn't do this check, you have to do this check somewhere else.
Just state the requirement and be clear that this is a requirement. That's what we need to do here, is say that it is not allowed, if you're doing deterministic encoding, to ever encode duplicate keys. You rely entirely on the encoder for duplicate key prevention when you're doing deterministic encoding. And you're not relying at all on the decoder for any conformance or checking, because that's the point of valid invalid, is that in some circumstances you can rely on the decoder to throw out invalid because it's too expensive for the encoder to actually create the validity. But I think what you're saying now is that with deterministic encoding, we are going to rely entirely on the encoder for map validity, and it's illegal to produce deterministically encoded CBOR with duplicate keys. You can never see that on the wire.
Joe?
So I think there's a philosophical issue here that we've got. There are two ways, or at least two ways, of checking that the thing that you received is correctly encoded CDE. So I might check as I'm decoding to ensure that that's true, or I might decode, re-encode, and ensure that I got the same bytes. There are probably 15 other ways of doing it. Those are the two that we've thought of. And if you're doing the second way, then no, you don't have to check during decode. It's fine. Or you might, here's a third way, which is you trust the sender, which I think is what Lawrence is arguing for. You trust that the sender has sent it correctly. So if I'm doing a cryptographic thing, I probably don't want to trust the sender because that's the whole point of what we're doing. And then I think supporting both of those other two ways of saying I check while I decode, or I re-encode to bytes, both of those are fine, completely valid implementation approaches. But if you're doing the one where you check during decode, then it would be nice to write down the rule set for that, just so that we understand what it is.
Thank you. So you covered my point here. Checking is expensive. Exactly. And that's why we have to discuss whether we want to do this or not. So the decoder checking has zero cost when you do the brutish approach, decode, then encode, and see whether you got the same bytes. Which maybe requires a little bit of luxury in terms of space and CPU time you have. And if you do the other thing, well, that's yes. So Lawrence says decoder checking has to be entirely optional. Only checking decoders have to do decoder checking. You can use a normal CBOR decoder and decode the thing, and you will be happy, but you do not get the properties that you get from a sequence in which you have a checking decoder. Yes. So the protocol at some point will say, you are using CDE, and you need to check the CDE encoding constraint when decoding. So that's what the security protocol designer will do. And for some other applications, you don't have to do that checking. Okay, I think that was a very useful clarifying discussion. So let me go on to, what's this? Yeah, there was some lag I didn't know how to handle. So given that we are using or providing an opportunity to do the validity checking for maps, we might want to look at the other basic validity that 8949 provides, and that is text string validity. Well, Lawrence, the point about a security protocol is that you cannot trust the encoder. So in that case, you have to do checking.
Yeah, I don't think that's true. If you're maybe it's a layering thing, but in terms of the determinism, I mean, no, you're not going to. In terms of the determinism, you can't. In producing a hash, you're receiving. Well, okay. All right, I'll think about this.
If it helps, I think it depends on the security protocol. Some protocols are set up so that you don't need this strictly. Others might do some re-encoding and then suddenly they might need it.
Yeah, but if I were on the ISG and would get a security protocol that doesn't do that checking, I would probably not let this through, because it's just a standard place where attackers will put their wedge and hammer on it.
So just to put that in context, so if you kind of made a suggestion to Cozy from scratch, it would not put the protected in a byte string in the first place, or because that's where I'm.
Cozy uses deterministic encoding only to compute signing inputs. So this is a different situation. And I'm talking about protocols that actually use the fact that something was deterministically encoded to relate the data model view, the application view on the data to what has been on the wire. And so Anders has this embedded signatures that require this probability. And these definitely are attackable using an attack of this kind. Okay. Yeah, so we definitely need a little bit more text about this than is in the current document. So maybe we can talk about text string validity briefly, given that we already are checking map validity. We might want to check text string validity because we cover, thank you, we cover all of basic validity if we do that. And yeah, this just means that both the encoder and the checking decoder will have to check that the syntax used in the text string is UTF-8. So encoders already can do that, and we would make that a part of the encoding constraints. So checking is expensive. Do we want to require that? Do we essentially want to limit the usefulness of CDE to those cases where we can bear this cost, where this cost is not an extreme addition to the costs we already have? Then we should include this, or we might want to say, oh, that's why we separate validity out, and this can always be checked later, so let's not check it now. True.
I mean, same argument for the other constraints. Like, this is a way for attackers to put a wedge in.
Yes.
And now they're attacking the UTF-8 implementation. Maybe this is a place where, like, the thing is simple enough and implemented correctly well enough. But I know that I've implemented UTF-8 recently, and I missed 3 of the constraints on my first pass, and then went through and did some more testing and was like, oh yeah, the other 3 constraints that I forgot. So it's pretty easy to mess up a UTF-8 implementation to make it take data that it shouldn't take. I would also argue that there are now UTF-8 checkers that use the wide instructions. So they're operating on 4 bytes at a time or 8 bytes at a time that are a lot faster. And so just checking for validity doesn't necessarily have to be as slow as it used to be.
Lawrence?
Okay, so determinism is orthogonal to security in terms of malformed input. the purpose of determinism is determinism. And one of the problems of this, I think, that happens in this working group a lot is that people kind of add on things to, they do have different ideas about adding on to, what's part of serialization and what's part of determinism. So I think we need to be really clear here that determinism is orthogonal to security. The criteria for security defending against bad input from attackers has to be, that belongs in security considerations. And it is a minimal standard or a minimal thing that everybody needs to implement in their work today, anywhere, whether they're doing determinism or not. So I would, and we kind of get this conflation because the purpose of determinism is usually for signing and hashing, so it's security, like that, but the input validity checking, to defend against attackers manipulating the input, to pop the stack or something like that. I think that's an entirely orthogonal issue from determinism. And let's keep determinism clean and about determinism, and not have any stories about like trying to defend against malicious input.
Thank you. So one reason why I wasn't so sure about this is that most people are not in the situation Joe was talking about, having to implement UTF-8, but people already have UTF-8 support, and that UTF-8 support is sufficiently hardened that this is essentially a non-issue. So the thing will blow up anyway, just after the CBOR decoder. That would be the usual situation, but of course that's not something we can rely on. Yeah, that's why that question actually is interesting, and I think Lawrence has a good point here. Yeah. Okay, I think we have collected useful viewpoints on this, and I'm not sure we have a decider right now that we can use, the tie break that we can use to find out which one we should do. So I'll just write both versions into the document, and then we can maybe all look at implementations a little bit more and sharpen our viewpoints on this. Okay, and let me just point out that there's, of course, the big area of tag validity, and CDE is entirely silent about tag validity. So that would be another case where if there is any validity checking needed, it needs to be at the application level. So we could just put text string validity into the same box that we put tag validity in, and say that's for the application to check. That's not something that CDE is about. Yeah, I'm not entirely comfortable, but good discussion. So I'm done with my slides. Obviously, there is a lot of text in this pull request, and looking at the diff can be a bit intimidating because so much text changed. But yeah, the reason is that we changed terminology here, and that, of course, is pretty pervasive when you do it. So given that we have 19 days until the internet draft deadline for IETF 124, I think we need to have a plan to get this finished until then. So in 2 weeks, we could have another interim where we look at the progress and also look at the agenda that we will build for IETF 124. And that requires that there is some feedback on the pull request. So I plan to do more editorial work on the pull request during the rest of this week. Of course, I would be happy if you could actually look into the document, but maybe save a full reread of the document for a point in time when some of the remaining redundancies have been removed, which should be at the end of this week. And then after we have done that, we have to see, do we have any other contention points? And Joe already mentioned that maybe we want to do something about non-trivial nans here. And I said why I don't think so, but that doesn't mean that that's the answer. And are there any other things we need to fix before we can finish this document? That's all I have. Oh, sorry. Lawrence?
Since we have some time, maybe we could talk a little bit about non-trivial nans. Is that okay?
Sure.
The encoding that doesn't have a name, or the unconstrained encoding?
Well-formed, yes.
Yeah, that we could call well-formed, yes. So my understanding is that that supports non-trivial nans just fine. And it's just like a streaming encoder. Non-trivial nans is like a special case, like a streaming encoder is a special case. So you just use the unconstrained encoding and say that's what you want, and then you could even say I want definite length only encoding with non-trivial nans as a way to special case that. Basically that's a custom serialization, but probably the way we will state custom serializations is in terms of deterministic encoding or in terms of definite length encoding. So if you want non-trivial nans with any of those, you just say, well, I want what unconstrained encoding does for floating point, and then you get them, just like you would for serialization for streaming encoders.
Christian?
So far, my understanding of those constraints was that adding a constraint does not that you can always use an instance that has an encoder that has a tighter constraint set with a more relaxed decoder. Now, wouldn't a more constrained encoder, wouldn't that having non-trivial nans as a feature go against that, in that all of a sudden using for example a CDE encoder that just does CDE all the time because it can will suddenly not produce those nans anymore?
If we were to say that CDE doesn't support the current encoding of non-trivial nans, then yeah, you'd have an issue. If we were to say, hey, there's this other tag you can use for non-trivial nans, then it would be an encoding decision issue. Mm-hmm. And it would still support the data model. We'd just do it using a different encoding.
Okay, but that means that still means that an encoder that okay, understood, yeah.
Yep.
Just means that I'd probably prefer a solution that uses the tag, because an encoder of CBOR as it is now will not produce those. If I understand what non-trivial nans are correctly, I will not produce those because it will just shorten the nans and lose the length information.
Yes, so that's one of the reasons why I've been pushing for the tag, is to make this, to turn this into an encoding decision rather than a data model decision.
Yeah, like a tag around a byte string or something.
Yeah, it would just be a tag that has a byte string that's either 2, 4, or 8 bytes long, and could only encode non-trivial nans, period. Anything else that was in those byte strings that was not a non-trivial nan would be rejected.
Yeah, I think that that's certainly one way to do things. The disadvantage is that we no longer can say that preferred serialization is a good default setting for a CBOR implementation. And I think that that's a relatively big diversion from what we have been having before. The cases where preferred serialization actually loses information are rather artificial. I cannot imagine that an implementation actually will have that problem because people who are working with NANs are working with a specific encoding size, and they know what the encoding size is. And the fact that at the transport level, when CBOR sends this encoding around, it saves a few trailing 0 bits, doesn't change the way that the implementation will handle that. But it does require a little bit of care, like the aside in I think 3.1, section 3.1 says.
So I would expect encoder libraries to support a definite length only encoding and a deterministic encoding. They may support an unconstrained encoding that allows you to sort of piece together the things you want out of for a special case. So I view the use of non-trivial nans as a very unusual, very special case. And if you're doing that, you might be not be taking an encoder off the shelf and using it as is, or you might have to go do something extra. And that's okay. I think that's a fine way to work. I mean, non-trivial nans are a very unusual, minuscule use case, much more unusual and minuscule than a streaming encoder. So that we're fussing way more about non-trivial nans than we are about streaming encoders, which are going to be much more common. I have no objection to the tag or other solutions. I just want to frame it up that way.
So I agree with what Lawrence just said. This is quite a small edge case. And I'll furthermore say that at least one, if not both of my implementations of CBOR are not interoperable with the current, with what's in preferred serialization for non-trivial nans. Basically, I only encode trivial nans, I only decode trivial nans, and so that information gets lost in my implementation. So there exists some implementations where sending a non-trivial nan will be not interoperable in the way that you expect. So that's just an existence proof. I'm not saying okay, I did it wrong, fine, whatever. But I think that's a data point. There may be others that have that issue. And then the other point I wanted to make, which is I sort of alluded to this before, but in section 561, paragraph 3, where it says nan values are equivalent if they have the same significand after zero extending both significands at the right to 64 bits. That is untrue. And the reason why it's untrue is the sign bit. So whether that's recoverable or not, I don't know, but that statement is just not true in 561 because it doesn't account for the sign bit. So that I think is an error in 8949. This is one of the errors that I've been trying to articulate in NAN handling in 8949. So that's something that we should at least consider.
Yeah, I'm trying to find the paragraph you are pointed to. Yeah, correct. So they have to have the same sign bit as well. So that's actually an errata that we can use. Yeah. So this was focusing on the part and not telling the whole story. Okay. So thank you, Lawrence, for pulling up this issue for the last 10 minutes. Anything else you want to pull up?
Okay, looks like we're done for today. All right, thank you everybody for coming, and we had a good discussion today.
Just hang on, I see Ira joining the queue. Was that? Sorry.
Yeah, this is not a change to CDE, but it's a question that came up, and I think continues to come up, about checks that need to be done when CBOR is used in a security-sensitive context, which is many of its uses, but that are not part of CDE or are not part of 8049 validity. And maybe validity checks are the ones that particularly happen. Do we need a document, or at least something as a running document within the workgroup about where these sharp edges are? Because it seems to me that maybe we need a document that says applications which are security sensitive should or must, but at least should, do these additional checks beyond the checks that would be conformant CDE or conformant 8449 CBOR. Anyway, that was the thought I had throughout this day. Thank you.
Yeah, my comment would be every use case is a security use case in that sense today. You know, there's security as in, you know, defending against, you know, malicious intent, and then there's security as in, like, we're going to use crypto and we're going to sign things or encrypt things. Deterministic encoding is about security when you're encrypting and signing, but every use case in this day and age is a security use case in the sense of defending against malicious attacks. So let's keep this all very straight. I mean, if we want to have a security considerations of like things to think about if you're just trying to defend against malicious input, that's fine. But that is a different document, and I think it belongs somewhere entirely else besides any discussion of serialization or security in the cryptographic sense.
I agree, Lawrence. My concern is that Karsten and others are saying, well, yeah, but you'd have to then make that the application level or you're at risk. So that's somewhere in some document, we ought to talk about that. And I was explicitly saying, I don't want to add more and more constraints, more and more requirements to this CDE document, because I think this is a black hole to do so.
Okay, violent agreement.
My approach to this would be to actually start with a wiki page and try to collect anything we have there. So right now my head is pretty empty on this. of course, there could be a general document that is about best practices in using CBOR in general. But one thing we try to do with this best current practice is to be comprehensive enough that people can use it to actually do their work and don't have to look at lots of other things. But if there is a set of additional things that people should be worrying about, we should collect that. And so the first thing I will do after this meeting is to create a wiki page.
Thanks, Carl.
Okay, are we now done? Anyone else have anything to say? Okay, thanks and see you next week. And thanks again to Marco for notes.
Thank you.
Next week.
Thank you. Bye.
Bye-bye.